Okay, in this video we're going to talk about the binomial theorem. And this may seem difficult, but it is really not. That's the purpose of a high school education, to learn the basics. If you pass up the basics, you lose. So we're going to start off from the basics and lead up to the binomial theorem, okay? So we're going to call this first part the study of power functions. And you'll get a hint on what that is as you venture through this. So don't get scared, because it's quite simple if you listen to and understand. Okay, let's say we were given the function x plus 1 to solve. Well, this function is already in a polynomial state, so we can either graph it or solve for x. And don't worry about polynomial if you don't understand that, which you should if you've taken algebra. But if you haven't, don't worry about it. I'm going to explain it a little bit later. So let's just say that y equals x plus 1. Okay, so y is equal to x plus 1. So now let's make a table of x and y values to graph this function. Okay, so we got x and y, and I have here when x equals 0, then y equals 1. Okay, and for the equation here, I say when x equals 0, x is 0, so you put 0 where x is, and then you say, well, only thing left is y equals 1. Okay, then when I say when y equals 0, when you put 0 for y, then you say 0 equals x plus 1. Well, to solve for x, you move 1 to the other side, and it becomes x equals minus 1. Okay, so now I have 2 coordinate points, and as you know, to draw a straight line, you need 2 points, right? So here it is, our 2 points. Okay, right here, 0 for x, 1 for y, minus 1 for x, 0 for y. Okay, so we've drawn the graph of this point. And any point you pick will be on this line for y. Like say we pick x equals minus 1/2, and we go straight up, boom. Right, that point is at x equals, is at y equals 1/2. Okay, so x equals minus 1/2, you put minus 1/2 in place for x. Minus 1/2 plus 1 equals y equals 1/2, and that's what it is. Okay, so we've graphed that. Now, suppose we were given the function y equals x plus 1 raised to the power of 2, or quantity x plus 1 squared. How would we transform this function into a polynomial? And the reason why we got to transform it into a polynomial is because there's no way to solve this the way the function is, in the condition is in now. You have to square it, okay, to get it into a polynomial state where you can solve for x. So let's see. We have y equals the quantity, parentheses called quantity, x plus 1, quantity, close, parentheses close, squared. This equation can be written as the squared exponent 2 means multiply x plus 1 by itself twice. So we have y equals x plus 1, quantity x plus 1, times the quantity x plus 1. Okay. So let's see how we would do that. And we would use what we call a FOIL method that you learned in algebra. Okay. I didn't learn the FOIL method because I learned algebra 40 years ago. So here, but I'll show you what the FOIL method is. You say x times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. Okay. Then what you do is you gotta, now let's call this function f of x, because y is a function of x. And I'm really calling it f of x because we're moving forward into the binomial theorem. So function f of x means that y is a function of x, okay? So we gather our terms. We have x squared plus x plus 1. Well, x plus x is 2x, okay? So now we have f of x. F is a function of x is equal to x squared plus 2x plus 1. Now if we choose, we can graph this function. Now suppose we were given the function f of x equals quantity parentheses x plus 1 raised to the power of 3. This function has an exponent of 3. How would we transform this function into a polynomial? Okay. So let's see. We have f of x equal to parentheses the quantity x plus 1 raised to the power of 3. Okay. The cube exponent 3 means multiply x plus 1 by itself 3 times. Since we know what a squared equation is, we just multiply one more time by x plus 1. So we have f of x equal x plus 1 times x plus 1 times x plus 1. Well, we already did the x plus 1 squared, so we just put that equation in there and then multiply by that one more time. Then we use the for method again. So we have x times x squared is x cubed. X times 2x is x squared. X times 1 is x. Okay? Then we come back to the 1. We have 1 times x squared is x squared. We have 1 times 2x is 2x. And we have 1 times 1 is 1. Okay? Then we add up like terms. We have x cubed, 2x squared, and x squared is 3x squared. And x plus 2x is 3x. And then we bring down our 1. Okay. Now suppose we were given this function, f of x equals x plus 1 raised to the power of 20. Well, what would you have to do? Well, you would have to transform this into a polynomial by multiplying it by itself 20 times. And that's a lot of work. Okay. You just saw what we did with 3 times. Okay. Now, well, suppose we were given this function, f of x equals x plus 1 raised to the power of minus 1/2. How many times do you multiply this? Well, that's kind of tricky. I don't know how you would multiply that times minus 1/2. Okay? So, there's got to be an easier method of doing this. Let's investigate a function, but this time, rather than using numbers, let's use all the variables for the function except for the exponent. Let's now look at the binomial theorem. Okay, the binomial theorem. A binomial is an equation with 2 terms. That's all it is. That's why it's called bi. So let's say we have 3y raised to the power of 3 minus 4. Well, term 1 is 3y cubed, and term 2 is minus 4. Okay? So that's why it's called a binomial, because it has two bi's in it. Okay? 2 nomials. Okay? A polynomial is an equation with many terms. It has 3x cubed minus 2x squared minus 5x minus 8. A binomial may also be raised to powers or an exponent. Let's investigate this. Okay. So we say the binomial may be raised to powers. So let's say I have the binomial a plus b raised to the power of 0, a plus b raised to the power of 1, a plus b raised to the power of 2, a plus b raised to the power of minus 1, a plus b raised to the power of minus 1/2. Anything raised to the power of 0 is 1. Okay? So all of these are polynomials, okay, or binomials, okay. So what is a plus b raised to the power of 0? Well, a plus b raised to the power of 0 is equal to 1. Anything raised to the power of 0 is 1. So 2 raised to the power of 0 equals 1. 129 raised to the power of 0 equals 1. Okay. X raised to the power of 0 is equal to 1. A raised to the power of 0 is equal to 1. Okay. So let's raise a plus b to different powers and see what we come up with. Okay. Like we had up here. Let's raise a binomial to powers. Okay. A plus b raised to the power of 0 is equal to 1. A plus b raised to the power of 1 equals just a plus b, right? We just raised it to the power of 1. This is the original equation or function. A plus b squared is a plus b times a plus b, as we've done before. Means multiply by itself 2 times. A plus b times a plus b equals a squared, like we did before. A times a is a squared. A times b is a times b. B times a is b times a. And b times b is b squared. Okay. Now we collect the like terms. We have a times b plus b times a. Well, b times a is the same as a times b. So that means that's 2ab. So a squared plus 2ab plus b squared. And there's our polynomial, okay, from a plus b squared, as we did just previously before, okay. Let's continue and raise a binomial to powers. Let's take a plus b raised to the power of 3. Okay, well, we have a plus b raised to the power of 1 times a plus b squared. And that's a plus b cubed. Because when you multiply like terms, you add the exponents, okay? So, since we already know what a plus b squared is, we can just multiply by a plus b one more time, okay? Because we just did a plus b in the previous video, the previous slide. So a times a squared is a cubed. A times 2ab is 2a squared b, because a times a is a squared. Okay. And a times b squared is ab squared. Okay. Now we go to the b. B times a squared is ba squared. B times 2ab is 2ab squared. And b times b squared is b cubed. Now we add our like terms, okay. So we have 2a squared b, and we had ba squared. Well, ba squared is just a squared b, and so that makes that 3a squared b, okay. And then we have a times b squared plus 2ab squared. Well, 2ab squared plus ab squared is 3ab squared. And then we have our last term, which is b cubed on the end. So now we have our polynomial, okay? And here's our polynomial, and here's our binomial inside of here, okay? Let's look at this polynomial and see if there's a pattern during the multiplication process, okay? We're going to look at this and see if there's some kind of pattern that's happening here, okay? Let's look at the exponents of a in our last equation. Okay, here's our exponents of a. A, when we first start out in our polynomial, we have a cubed, then a squared, then a to the 1 power, then we have no a. A is gone. Well, in front of this b is really a 1. It's understood to be a 1. So if that's a 1, then that must be a to the 0. A to the 0 is 1, okay? So you see here we have a to the 0. A exponents decrease from 3 down to 0. 3, 2, 1, 1, 0. 3, 2, 1, 0. Okay, let's look at the b squares, or the b exponents, okay? The b exponent, here we have a cubed, but there's no b exponent there. So that must be b to the 0, because there's a 1 in front of this a cubed. We have b to the 1 here. We have b squared here in the next binomial, nomial, and then we have b cubed, okay? So b decreases from 0 down to 3, all right? So both a and b increase and decrease to 3 because 3 is the exponent of our binomial equation, okay? That's cubed. Our binomial has been cubed, okay? So it decreased to 3. So because of that exponent, it decreased to 3. If this exponent was 4, they decreased to 4. If this exponent was 20, they decreased and increased to 20. Okay, let's see if we can write a formula for this activity of increasing and decreasing of a and b. Okay, we have our cubic function returned again. So a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Let's label the exponent in the binomial that's been cubed here as n, okay? So rather than calling it cube, let's call it some n, whatever n is, okay? Now let's label the decreasing of a by n minus k and the increasing of b as k. And I want you to watch what happens here, okay? So we call a raised to the power n minus k times b to the k. Let's see how this works if we can get this to give us our polynomial back, if we plug in the numbers for n and k. Let's let n equal 3, like we had up here, and k to increase from 0 to n, or 3, as we did before here, okay? So here's our function again, a plus b raised to the power of n, and we say we're going to let that equal to a raised to the power of n minus k plus b to the k. So when n equals 3, which is right there, and k equals 0, a is equal to 3 minus 0, n minus k is 0, times b to 0. Well, if we put b to 0 as 1, right? Okay, 3 minus 0 is 3, so that gives us a cubed. When n equals 3 and k equals 1, we have a to the 3 minus 1, see, n minus k, times b to the 1. Well, 3 minus 1 is 2, so we got a squared plus b. When n equals 3 and k equals 2, we have a raised to the power of 3 minus 2 times b to the 2, raised to the power of 2. And 3 minus 2 is 1, we get a raised to the power of 1 times b squared. Okay, now to get our polynomial, we have to add each of these terms. A cubed equal a squared times b plus a raised to the power of 1 times b squared. So let's call this addition we're going to do a summation. And we call this a summation sign. So this summation sign is telling us, as we plug in these numbers from k equals 0 to n, we're going to add each term we get, okay? So here we go. A plus b raised to the power of 3 equals the sum from k equals 0 to 3 of each one of these terms, and we add them up. Here we go. A cubed plus a squared b plus a times b squared plus b cubed. We obtain the polynomial, but not the coefficients. Okay? You remember our coefficients were 1, 3, a squared b plus 3ab squared plus 1b squared. We got the ones, we don't have the threes. To get these coefficients is quite simple, but first we have to discuss Pascal's triangle and how to choose k terms from n items. Pascal's triangle puts all of this into perspective for us. First, let's talk for factorials. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. That equals to 120. 0 factorial is equal to 1. Okay. 6 factorial divided by 3 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. That's what 6 factorial is. 3 factorial is 3 times 2 times 1. Well, the 3 times 2 times 1 cancels in the denominator and the numerator. So that leaves 1. So that also leaves us 6 times 5 times 4. 6 times 5 times 4 is equal to 120. Okay. 4 factorial divided by 0 factorial is equal to 4 times 3 times 2 times 1 divided by 1, because 0 factorial is 1, and that's equal to 24. And that's about all you need to know about factorials, is to recognize how to do factorials. And that's it. Okay. Let's talk combinations. You have 3 boxes and 5 balls. How many ways can you pick balls to fill the boxes? Okay. There's such a thing in combinations called n choose k. And the C is for combinations. So that equation is n factorial divided by k factorial times the quantity n minus k factorial. This means n choose k. Okay. So we have 5 balls and we have to choose 3 to fill boxes. How many combinations do we have? Well, we have 5 balls, we got to choose 3. So 5 factorial, n is 5. And we know what 5 factorial is: 5 times 4 times 3 times 2 times 1. And 3 factorial times 5 minus 3. Well, 5 minus 3 is 2, so that's 2 factorial. 3 factorial times 2 factorial. 3 factorial, we know that's 3 times 2 times 1. And 2 factorial is 2 times 1. So 2 times 1 cancels, and the 3 cancel. That leaves us 5 times 4 and 2 times 1. 5 times 4 is 20. Divided by 2 is equal to 10. So we have 10 different ways we can choose 3 balls from 5 to fill those boxes. Okay. Another way to say n choose k is, rather than write this equation out above here, n choose k, we can write n choose k in parentheses, or 5 choose 3, as we did before. Then plug it into the equation and we get 10. 5 choose 3. Okay, that's another way of writing that. Back to our cubic equation to determine the coefficients. Here we are. We have a plus b cubed is equal to the sum, because we found out we had to add all of those when we plug into this equation, from k equals 0 to 3. And it's 3 because n is 3 over here on our cubic equation. So the first term, when we plug in the first terms from 0, k equals 0 to k equals 1, k equals 2, and k equals 3, with n stays constant as 3, we get a cubed plus a squared plus b times b. Well, let me start that over. We get a cubed plus a squared times b plus a times b squared plus b cubed. Okay. We obtained the polynomial, but not the coefficients. Remember, we didn't get the coefficients. To get these coefficients is quite simple. But first we have to discuss Pascal's triangle and see how to choose n choose k, and how to n choose k terms in. Well, let me start that over. To get these coefficients is quite simple, but first we have to discuss Pascal's triangle and see how to n choose k terms in the Pascal triangle puts all of this into perspective. So let's look at that. Pascal's triangle. Okay. Remember these, our binomial, we raised to different powers. Okay. So a plus b raised to the power of 0 is 1, as we know. Anything raised to the power of 0 or 1. A plus b raised to the power of 1 is just a plus b. Okay. So we put a out here and the plus under the 1 and b. A plus b squared is a squared plus 2ab plus b squared. Well, we put a squared on the end, put the plus under the a, 2ab under the plus under the b, and then on the end we put b squared. A plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. We put a cubed on the end, plus the plus under the a squared, 3a squared b under the plus under the 2ab, 3ab squared under the plus, and put the plus under b squared and put b cubed on the end. And what you do is you look at all the coefficients in front of these variables. On the top we have 1. What's in front of the a? A 1. What's in front of the b? A 1. What's in front of this a squared? 1. What's the coefficient in front of ab? 2. What's the coefficient under b in front of b squared? 1. Let's move down to the next one. What's the coefficient in front of a cubed? 1. What's the coefficient in front of a squared times b? 3. Put the plus under here, under 2ab. What's the coefficient in front of ab squared? 3. And what's the coefficient under b cubed? 1. If we remove all the variables and just put the coefficients in, we get Pascal's triangle. We have 1 on the top, AB, we had 1 in front of AB. Our a squared, a plus b squared, we had 1, 2, 1. And on our third row, we have 1, 3, 3, 1. That was our coefficients. So from the top, we go from row 0, we call that row 0, 1, 2, 3. That's our cubic equation. If we're looking for a plus b raised to the power of 5, we come to row 5. And we'll have 1, 5, 10, 10, 5, 1. Now, the simple thing about Pascal's triangle is all you need to know is 1 is on the top, and the next row, 0, 1, is 1, 1. Well, how do you get the next row? Well, you add the numbers below that. Okay, so this is 1, 1. So if you add 2 plus 1, that's 3. 2 plus 1 is 3. Okay, and then there's 1 on the end. So we're at the third row. How do we get the fourth row? Well, 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Now we're on the fourth row. How do we get the fifth row? 4 plus 1 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And 1 is on the end. So we're on the fifth row. How do we get the sixth row? Well, we have 5 plus 1 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 15 is 15. 5 plus 1 is 6. And you'll notice at the middle of the triangle repeats itself. 35, 35, 21, 21, 7, 7, 1, 1. How do you get the 10th row? That's 0 row here, 0. This is the 5th row, 6th row, 7th row, 8th row, 9th row, 10th row. This is a plus b raised to the power of 10. How do you get the 10th row? Well, 9 plus 1 is 10. We had the 9th row. We had the 9th row. 9 plus 36 is 45. 36 plus 84 is 120. 84 plus 126 is 210. 126 plus 126 is 252. We're at the middle of the triangle. So now we don't need to add this side because then we know it repeats. So we'll just plug in the next numbers from the other side, which is 210, 120, 45, and 10. That's Pascal's triangle. But there's a lot of work here, okay? There's a lot of work to get Pascal's triangle, as you can see. You have to add up the rows. So for our equation, the coefficients are on the third row. Okay, so we come down to the third row and we see the coefficients are 1, 3, 3, 1. 1, 3, 3, 1. And surely that's what our coefficients are. Okay. Pascal's triangle, n choose k. How many ways can we choose a and b? Okay. We saw that we had a plus b raised to the power of 0, which is 1. Okay. A plus b raised to the power of 1. Well, a plus b, there's only one way to choose a plus b. Okay. A plus b squared. What about when it is squared? How many ways to choose? What about when it's cubed? How many ways to choose? Okay. So we have to investigate that. So let's look at that. A plus b squared is a plus b times a plus b. A squared comes out to be a squared plus 2ab plus b squared. How many ways can we get a squared and b 0? See a squared here? A is a squared, but there's a b to the 0 in front of there because b to the 0 equals 1. How many ways can we multiply this equation and be guaranteed we get a squared? Well, there's only one way to choose a squared and b 0. Okay? How many ways to choose a times b? Well, we got a times b and b times a. So there's two ways to choose a to the 1, b to the 1, right here. A to the 1, b to the 1. There's two ways to do that. How many ways to choose b squared? Well, b times b is b squared. There's one way to choose b squared and a to the 0. There's a to the 0 in front of that b. There's only one way. So let's rewrite our equation for a plus b cubed in Pascal's triangle using n choose k, as we just discussed. Okay, so previously we had a plus b raised to the power of 3 is equal to the sum from k equals 0 to 3, because we knew that each time we plugged in n minus k, from k being 0, 1, 2, 3, we had to sum those, add the results. Okay, and now we know to get our coefficients, we have to do n choose k from n equals 3, from k equals 0 to n equals 3. K equals 0, k equals 0, k equals 0 for the first one, k equals 1 for the second one, k equals 2 for the third one, and k equals 3 for the fourth. 0, 1, 2, 3. That's 1, 2, 3, 4. Okay. Well, k equals, let's do this. So when we start out, k equals 0 and n equals 3. Well, 3 minus 0 is 0, and b to the 0 is 0. So that's a cubed. Okay. But now we have to find the coefficient. Well, the coefficient is n choose k. And k is 0. So we have n is equal to 3 factorial, and k is equal to 0. So it's 3 factorial divided by 3 minus 0 times 0 factorial, because k is 0. So 3 minus 0 is just 3. Okay. So 3 factorial is 3 times 2 times 1. And 0 factorial is 1. Well, 3 factorial divided by 3 factorial is just 1. So that's 1 for the coefficient in front of a cubed. Okay, let's go to our next one. 3 choose 1. So 3 factorial again, 3 times 2 times 1. K is 1, so that's 1 factorial. Times n minus k, and k is 1, so that's 3 minus 1 is 2 factorial. I didn't include the 1 factorial, because 1 factorial is just 1. Okay. 2 factorial is 2 times 1. So 2 times 1, 2 times 1 cancel. Then the numerator and denominator, that leaves us with 3. So for our second term, our coefficient is 3. Let's go to our third term. 3 choose k, which is 3 choose 2. K is 2. 3 factorial divided by 2 factorial, k is 2, times quantity n minus k, and n is 3 and k is 2. 3 minus 2 is 1, so that leaves 1 factorial, times 2 factorial. Well, 2 factorial is 2 times 1, and the 2 times 1 is cancel here, and that leaves us 3. Okay. I forgot to put my 1 in there, but that's 2 times 1. Okay. And that leaves us 3. Let's go to our last one. 3 over 3. 3 choose 3. So 3 choose 3 is 3 factorial divided by k is 3, 3 factorial, times the quantity n minus k, with k is 3. 3 minus 3 is 0. So that's 0 factorial is 1. So we have 3 factorial times 1, which is 3 times 2 times 1. We have 3 factorial times 0 factorial. 0 factorial is 1. So that's 3 times 2 times 1. With the 3 times 2 times 1 divided by 3 times 2 times 1 is equal to 1. So the summation sign says we have to add all of these up. If we add all of these up, 1, 3, 3, 1, and put in here 1, 3, 3, 1, what we get? The coefficients for our cubic. We have our cubic equation here. A plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. And this is exactly what we saw from Pascal's triangle. Okay? And what we're going to do is we're going to take this n choose k and apply it to Pascal triangle. Okay? N choose k, when 0, 0, 0 over 0 equals 1. 0 factorial divided by 0 factorial times 0 minus 0 factorial is equal to 1. When 1 choose 0 and n choose k, if n is 1 and k is 0, that comes up to 1. And 1 over, when n is 1 and k is 1, that comes up to 1. So all of these endpoints come up to 1 on the right side, and all of the endpoints on the left come up to 1. And the internal parts give you what your coefficients should be. Okay? As we see here. Now compare this to the previous Pascal's triangle. 2 plus 2 is 1. 2, n choose k, which is 2, n is 2, and k is 2 is equal to 1 right here. N choose k, n is 2, k is 1 is equal to 2. Okay? Right here. And we see that is Pascal's triangle. The same. So for our equation, the coefficient on the third row is on the third row, because we have our binomial raised to the power of 3. If the binomial was raised to the power of 5, we'd be on the fifth row here. So now we can write the binomial theorem as the binomial equation is equal to the summation as k equals 0 to n times n choose k times x raised to the power n minus k times a to the k. Gives the polynomial, n choose k gives the coefficients. Let's say that we were asked to solve this equation below. X plus 1 raised to the power of 10. Well, x is in the place of where I had a, and 1 is in the place of where I had b. So you just replace those. Okay. To here. Okay. Now we can do that. All right. Next video, we'll tackle these functions. X plus 1 raised to the power of minus 5 and x plus 1 raised to the power of minus 1/2. This is the same song, but with a little different dance step. But if you study what we went through in this video, you'll have no problems. Okay. It'll take you a little, there's little advanced math there, but I will explain it to you. Okay. Until next time. I hope you learned something. Walk through this video a couple of times and make sure you understand it. And you'll see how mathematics works with this binomial equation. Thank you.